Hello everyone, this is DSA Zindabad. Today we are going to solve the sixth question of Arsh Goyal DSA sheet, and the question is best time to buy and sell stock. Now let's look at the problem statement. You are given an array prices where prices is the price of a given stock on the ith day. You want to maximize your profit by choosing a single day to buy one stock and choosing a different day in the future to sell that stock. And you need to return the maximum profit you can achieve from this transaction. If you cannot achieve any profit, return zero, right? Now let's look at the example. Let's take this example, which is 7, 1, 5, 3, 6, 4. Now, first of all, let's try to understand what the problem statement says. It says, let's say if you are buying this stock on this day, right? On the ith day, then you can sell that stock in the future days. You cannot travel back in time, right? Let's say if you buy a stock on ith day, you can sell it on the consecutive days, not on the previous date, right? Let's say if you buy the stock on this date, then you can sell that stock only on the consecutive days, right? Only on the next days which follows 5, right? Not in the backward direction. This is what the problem statement says, right? Now, looking at this example, let's try to guess the output, right? Let's say if we buy the stock on the 0th day, right? On this day, then let's say we sell this stock on this day, then there is no profit, right? Profit comes when future price is greater than the current price, right? Current price. Since there is no element which is greater than 7. So when we are buying this stock on the 0th day, then there is no profit, right? Let's say we buy the stock on this day, right? Element is 1. So we can choose to sell the stock only on the following days, right? Which is 5, 3, 6, 4. And out of this, let's say we sell the stock on this day, right? So our profit will be 5 minus 1, which ultimately equal to 4. Let's say we decided to sell the stock on this day, then the profit will be 3 minus 1, 2, but 2 is still less than 4. So our maximum profit is still 4. Let's say we decided to sell the stock on this day, then ultimately 6 minus 1 will be equal to 5. Since 5 is greater than 4, so we'll update our max profit by 5, right? And 4 minus 1 will also be equal to 3, which is less than 5. So our maximum profit will remain as it is, which is 5. So as you can directly see on the explanation, buy on the day second, price equal to 1. Buy on the second day when the price equal to 1, and sell on the day 5. On the day 5, this is right. Then our profit will be maximum, which is 6 minus 1 equal to 5. Note that buying on day 2 and selling on day 1 is not allowed, because you must buy before you sell, right? Because whenever you like want to sell the stock, first of all, you need to buy that stock before selling it, right? Let's say you guys be like, let's say find the maximum element from this array, which is 7, and the minimum element is 1. And let's try to subtract them, which ultimately will be equal to 6. But the problem statement says you cannot traverse back in time, right? This is not allowed. That's the reason why we are getting 5 as our profit, right? Because we cannot traverse back. Now let's look at the second example. It says 7, we are given 7, 6, 4, 3, 1, right? And the output will be 0, because after 7 we do not have any greater element than that of the 7. And same goes for 6. As you can see, for we have 4, 3, 1, all the elements are still less than 6. Same goes for 4, all the elements are less than 4. Same goes for 3, and 1 is less than 3. That's why we need to return 0, right? It is also mentioned there, if you cannot achieve any profit, then you need to return 0, right? I hope the problem statement is clear to all of you guys. Now let's jump into the approach. So now, first of all, let's talk about the brute force approach, right? You guys might be thinking, first of all, let's try to take the maximum and minimum and subtract them. But this approach will not work, because we cannot traverse back in the array, right? This is the reason. Now let's try to think of some other approach, like how can we approach this solution, like uh, naive approach. Let's take this example: 7, 1, 5, 3, 6, 4. Right. First of all, we need to find out the maximum profit out of this array, right? Maximum profit. So let's say we are at this element. First of all, what we are going to do, we'll traverse all the complete array and try to find out whether we have our maximum profit greater than that of the zero or not, right? Let's say we have 7. For 7, there is no element which is greater than 7. So ultimately, its profit will be equal to 0. Now, when we move to 1, now again, we'll traverse over the complete array and we'll check whether we have a profit or not. Let's say 5 minus 1 equal to 4. Now we'll go to this 3. 3 minus 1 equal to 2, but 2 is still less than 4, so it will remain as it is 4. Now moving on to 6, it will equal to 6 minus 1 equal to 5. So we'll update our maximum profit by 5. Now moving on to 4, we'll check 4 minus 1 equal to 3, and 3 is still less than 5. So we'll not update our maximum profit. Now moving on to this element, we'll now traverse over the remaining array, right? Which is 3, 6, 4. Now, since 3 is less than 5, so we cannot sell the stock on this day. Now, 6 minus 5 will be equal to 1. Since our maximum profit is 5, which is greater than 1, so our maximum profit still remain the same. And now moving on to 3, since 6 minus 3 equal to 3, but it is still less than 5. So we'll move to 4. 4 minus 3 equal to 1, still less than 5. So ultimately, our profit will be equal to 5. So this is what the brute force approach is. This approach says we are going to traverse the array again and again for each and every element, right? So now let's try to discuss the time and space complexity for the same. Since we are traversing the array again and again for each and every element, so it will require big of n square. And the space complexity would be big of 1, since we do not require any extra space, right? So now let's try to decrease the time complexity, right? What I mean to say, let's try to optimize this approach. Now we want to traverse the array only once. Traverse array only once. Now, how can we achieve this? And we have given a some array, right? And we just need to traverse this array in a single pass, right? So how can we achieve this? So for this, and we also keep this thing in our mind, like we need to solve this question, this problem, like using big O of 1 space complexity, right? Because ultimately we are also optimizing our solution. So its space complexity would be big O of 1 and time complexity should be big O of n, right? So for this, what we'll be doing, we'll initialize three variables, which are buy price, uh, and there is current price, and there is third one is maximum profit, right? We have these three variables because we are not using any other data structure, no vector, no array, right? No vector, no extra space. So we have to deal with the pointers or the variables, right? That's why we take three variables, and this approach will clear to all of you guys when I do the complete diagram for the problem, right? Now let's take this example, how we are going to solve this problem, right? Let's take this example for the same: 7, 2, 4, 5, 1, 3, 6, 4. And first of all, we need to keep these things in our mind. Only update buy price if new price is lower. What do I mean by this line? If new price is low. This means like buying price should be as low as possible, right? Before we need to maximize our profit. That's why buy price should be low. And when we're going to sell the stock, when new price is greater than buying price, right? When new price is greater than buying price, then we need to sell. And the third thing is how we can calculate the current profit, uh, which is very much simple. Current profit will be equal to current price minus buying price, right? And when we need to update our max profit, when our current profit is greater than max profit, then we gonna update our max profit, right? Update max profit whenever it is needed. Whenever needed, right? We need to keep these four things in our mind, right? Now let's do a try again on this example. Let me write this thing again. 7, 2, 4, 5, 1, 3, 6, 4. So initially our buying price will be nums of 0. Let's say this is our num set. So this will be our buying price, right? So let's make these variables here buy price. And this is our current profit. And the third one is max profit, right? So initially our buying price is 7, right? And our current profit will be equal to 0. And our max profit will again be equal to 0, right? Now, when we move to 2, now this is our new price. Since there is this condition, when we need to update our buy price, when new price is less than that of the buying price, right? So we'll update this to 2. Now we'll check. Now we'll again increment our pointer to this, and our buying price will remain as it is, right? Now, since we can see like 4 is greater than buying price, so there is no need to update our buying price. Now we'll calculate our current profit. Now let's try to sell the stock on this day, right? So our profit will be 4 minus 2 equal to 2. So this will again be equal to 2. Now we'll see, we can directly see like 2 is greater than 0. So we'll update our max profit to 2, right? Now moving on to this. Now again 5 minus 2 is equal to 3. And 3 is great. We'll update our current profit to 3, and 3 is greater than 2. So we'll update it to 3, right? Now moving on to this, as we can see, 1 is less than 2, right? 1 is less than 2. So we'll update our buying price to 1, right? We'll update our buying price to 1. Now we'll check this thing. Increment our pointer to 3, and 3 minus 1 equal to 2. So, but our current max profit will remain as it is since 2 is less than 3, right? Moving on to 6, as we can see, like 6 minus 1 equal to 5, and our current profit will be equal to 5, and max profit will also be equal to 5 since 5 is greater than 3, right? Now, moving on to 4, since 4 is 4 is like less than 1. No, sorry, 4 is greater than 1. So there is no need to like update the buying price. So 4 minus 1 will be equal to 3, right? But still our maximum profit will be equal to 5 because 5 is greater than 3. So at the end of this, like after traversing the complete array, we'll find that 5 is our maximum profit. Maximum profit. So we need to return this. I hope this approach is clear to all of you guys, like why we are maintaining three variables over there like buying price, current profit, and maximum profit. Current profit is to track the current profit, like when we sell stock on a particular day, and maximum profit is for storing overall the complete profit, right? Which is there, which is of like maximum value, right? And buying price needs to be updated when we find that new price is less than that of the buying price, right? I hope this approach is clear to all of you guys. Now let's try to code this thing up. So here is the question. Now let's try to put this thing. Buy price will initially be pointing to the start of the array, right? And this is our max profit, which will be initially equal to 0. Now we'll run our loop from int I equal to 1 till prices dot size, and we'll increment our pointer. Now if we find new price to be less than that of the buy price, then we need to update our buy price to the new price, right? Else we need to calculate our current profit, which will be equal to new price minus buy price, right? And our max profit will also be equal to current profit and max profit. Now we'll return our max profit. So let's try to submit this thing. It runs perfectly fine. This code runs perfectly fine. Now let's try to discuss the time and space complexity for this problem, right? So here is the code. Since we are just initializing two variables, so it will require big of one time. And as we are iterating over the array only once, it will require big of n time. So ultimately, its time complexity would boil down to big of n. Since we are not using any extra space, so its space complexity would become big of 1, no extra space, right? And one more thing, guys, this problem is the example of like Cadane's algorithm. I'll also attach the article link for how Cadane's algorithm works in the description below. You can uh, refer the Cadane's algorithm from there, right? I hope this approach is clear to all of you guys. Thank you so much for viewing the video till the end. Please like, share, and subscribe and comment if you have any doubt. Thank you so much.